This is a video on acid-carbonate reactions for the chemical world topic for Year 9 Science. So acid-carbonate reactions, having talked about acid-base reactions, acid-metal reactions, and now onto acid-carbonate reactions, they all involve a common trend, and that's naming the salt, as you'll see in this case. So acid, if you mix an acid with a metal carbonate, you'll get salt, water, and carbon dioxide gas. So an acid is typically aqueous. Okay, it's a solution. It's a liquid. A metal carbonate, so this is a metal latched onto a carbonate. And carbonate, the polyatomic ion for carbonate is CO3 2-. Okay, it's made of carbon and oxygen. That's where the word carbonate comes from. Carbon for carbon, 8 for oxygen. Okay, it's a polyatomic ion because it's got 2 or more atoms stuck together. In this case, carbon and oxygen. The salt is a solid that's formed. The water is typically a liquid. And the carbon dioxide gas, as the name suggests, is a gas. Here is a memory device I've been using over the years to know what the products are. She went crazy. S for salt, W for water, C for carbon dioxide. Now, this is not a statement against women or anything like that. It's just an expression with no intention at all. So please, no one take this seriously. Okay, if it was B, I'm sure I'd write boys. If it was H, I'm sure I'd write he went crazy. Okay, so I'm not attacking anyone or anything here. It's just an expression. Okay, and my female students laugh at this a lot. So it's just an expression, and it's just to help you memorize the products. So she went crazy. Salt, water, carbon dioxide. And it's just doing examples from here. So let's do an example. Example 1. Let's do a common one. Let's do calcium carbonate plus hydrochloric acid. So just like before with acid-metal reactions and acid-base reactions, follow a series of steps. So step 1 is to write down the products. Remember, she went crazy. S for salt, W for water, and C for carbon dioxide. Yes. Step 1. Step 2 is to identify the salts. Okay, it's the same as before. So salts are made of ionic compounds. They're ionic compounds by definition, and they're made of a metal and a non-metal stuck together. So once again, eyeballing the equation above, where do you see the metal? The metal is calcium. Okay, it's not carbonate. Carbonate's a non-metal. It's made of carbon and oxygen. They're non-metals. So it's calcium, and the non-metal, as before, comes from the acid, which is chloride. Chloric becomes chloride. Okay, and that's your salt. Let's do another one. Let's do sulfuric acid plus zinc carbonate. Just as before, let's do some steps. Step 1 is to write down the products. Okay, in this case, salt, water, carbon dioxide. Step 2, identify the salt. Metal plus non-metal. Metal, looking at the expression there, is zinc. Zinc is a transition metal. Non-metal name comes from the acid. Sulfuric, remember, becomes sulfate. And that's your salt. I'll do one more because it's straightforward. Example 3. Suppose we have, actually I'll do 2 more. Let's suppose we have copper carbonate plus nitric acid. So I'm using the 4 common acids as was the case before: hydrochloric acid, sulfuric acid, nitric acid, and acetic acid. Step 1, write products. Salt, water, carbon dioxide. Step 2, identify the salts. So the salt, metal and non-metal. The metal is copper. Copper is a transition metal. Non-metal comes from the acid. The nitric becomes nitrate. And there you have it, that's the salt. Last, final example. Suppose we have acetic acid and magnesium carbonate. Step 1, write products. Salt plus water plus carbon dioxide. Step 2, identify the salt. Metal plus non-metal. The metal is magnesium. Magnesium is in group 2 with calcium. So magnesium is what we write. Non-metal comes from the acid. Acetic, if you recall, becomes acetate. Magnesium acetate is the salt. And that's acid-carbonate reactions in a nutshell. It's the same idea as before with acid-base reactions and acid-metal reactions. So these are the three main types of acid reactions explored in Year 9 Science in the Chemical World topic from the Good Science textbook for Year 9 and Year 10.